All right, so we're going to do a different equation because I didn't know that there was this one thing they were going to do to you guys in Math 3, but they do it. They did it on the released exam, so I'm going to show you an example like that. So we're going to do y equals 2 sine, and then we're going to say pi fourths x minus 2. Yeah, what's weird about this one? It's got a pi in it. That's strange. Okay. Yeah, and it's got a 4 on the bottom. Okay, so the amplitude is still pretty easy, though. What's the amplitude? 2. Okay. To find the period of the graph, we have to do 2 pi divided by the number in front of x, which is pi fourths. And we have something divided by a fraction, which means keep it, change it, flip it.
Wait, so you can't just like cross out? You know, like...
You kind of can. It depends how quick your brain is with that sort of thing. So 2 pi multiplied by 4 over pi, what happens with the pi's? They cancel, and you get 8. So the period of the graph is 8, which is interesting because we're used to the period of the graph being like 2 pi or pi halves or something with pi in it. Well, since the b had a pi in it, it got rid of the pi and the period. So now the period is just like a normal number. Okay, so I like to do sets of 4 or sets of 8 for my boxes. So if you guys want, we could do 8 boxes equals 8.
Yes.
Or do you want to do 8 boxes equals 8? Okay. So 2, 4, 6, 8, 10, 12, 14, 16.
Oh my gosh.
Okay. And then we have an amplitude of 2, but we are going to be shifting the graph down 2. So even though on the video I often did 2 boxes equals 1, I can't do that this time because that would be too big for us to be able to do an amplitude of 2 and then shift the whole thing down. So I'm going to go by 1s. And remember, when we do these graphs, we always have to label everything because they're so different each time. Like the labels will be different at least. Okay. Does anyone remember what I do if my graph has been shifted up or down? Yeah, so this is where like my blue line was the x-axis, but I went ahead and I drew another horizontal line at +1 because the entire graph shifted up 1. So where are we going to draw the horizontal line this time?
Negative.
Okay, so go ahead and draw another horizontal line down at -2. And this is the only reason I would use a marker, actually, is so that I could differentiate between what my x-axis is and then how much I've shifted it. So I'm shifting it down 2. Okay. And it's a sine graph. The period is 8, so we're going to start at 0. And where do we end it? 8, because that's the period. And then we hit 0 in the middle, which is at 4. In between the first 2, we go up 2. In between the second 2, we go down 2. Okay? And then we do the whole thing again. So beginning, end, middle, up 2, down 2. And we could do it over here too. Beginning, end, middle, up 2, down 2. And we make sure that when we connect these, we have that U shape So it shouldn't look like a zigzag. It should look like a wave. And we make sure that we put arrows on each end, because these do keep going forever. And how do you check to make sure you did it correctly? You should be able to trace it with your finger, and your finger shouldn't stutter at all. It should just be like a smooth up, down, up, down, up, down.
Would you get points taken off if they look more zigzag?
If they look what?
If they look more like a zigzag.
Yeah, you want to get full credit for that. It's kind of like, it'd be like you were drawing, remember in the beginning of the year we did absolute value graphs, those were V's, and we had parabolas, and those are U? It's the same thing as if you draw a zigzag, it's like, oh, but you're drawing an absolute value graph that's connected to other absolute value graphs instead of actually drawing a sine curve. In fact, no, not quite. If you put an absolute value sign in a sine curve, it would make it kind of have some V shape to it, but it would still curve. I think it ends up making it like bounce. Let's try it. Actually, I did want to show you guys how to graph these in your calculators. So go ahead and grab a calculator. So we're going to go back to the beginning example. There is kind of a little trick to graph these to make sure your window is written in such a way that it's easy for you to see the graph. So let's go ahead and we're going to type in sine x. So we're hitting the sine button, sine x. And when we graphed this, did we graph it in terms of radians or degrees? Radians, I can tell by my measurements, right? Pi halves, pi, 3 pi halves. Those are radians. So I'm going to hit the mode button and make sure that my calculator is in radians. Okay, so let's say that I want my graph to match what I graphed on here. So if you can see what I did on here, I went from -2 pi all the way, this would have been 4 pi. Does that make sense? Okay, so I can hit my window button and I can say from -2 pi, see how I typed in -2 pi? When I press enter, it's going to turn it into a decimal. So I can press enter to 4 pi. Okay. Okay. And then each of my little boxes, since I had 1 pi is 4 boxes, then each of my little boxes is 1/4 of a pi. Does that make sense? So now for x scale means how often do you want me to put the little notches, the like little divots on the line. So I'm going to go ahead and put pi fourths, so that my little notches on here are going to match what's going to be on my calculator screen. Okay, and then for x min, I'm going to put -2, and for x max, I'm going to put +2. You mean y? Sorry, y min and y max, thank you. And then these, they went by 0.5, so if I want it to match what I did on my paper, then I'll go ahead and make my y scale 0.5. So if I do that now, what I've done in my calculator is I've made the window exactly what I drew. Does that make sense? Okay, so now if I... Yep, I did -2 pi, 4 pi, this is pi fourths, and then -2, 2, and 0.5. The y scale, I did 0.5. So I just made everything match what I had graphed. And then now I should be able to compare it, and ours is a little squished because our window is a little bit more square than our picture is here. But do you guys see how it matches it? Okay, so it's harder to compare your graph with the calculator if your screens don't match up. So what I did is I took my window and I made my window kind of match what I had drawn. Does that make sense? Okay, let's try it with the next one. So with this one, I didn't graph very much of it. So let's say I want to check just from like here to here. So I'll hit the y equals. I'm going to type in this part right here, so sine 2x. And then if I only want to check from here to here like this, that would just be from 0 to 2 pi. Does that make sense? Okay, so I'll type in 0 to 2 pi. 0 to pi. I still said that 4 boxes equals 1 pi, so that still means that 1 box is 1/4 of a pi. So I'm going to go ahead and leave my x scale the same. For my y scale, I still went from -2 to 2, and I still did 0.5 for every box. So I'm going to leave my y the same. And now if I graph it, it's going to match what we drew, but just from 0 to 2 pi. You guys see that?
My calculator is not showing the graph line.
It might be if you're still in degrees.
Wait, can you go back to this part again, just so you make sure, like, where you
The window?
Yeah.
So 0, 2 pi, pi fourths, -2 to 0.5.
What scale is 0.5?
Y scale. Okay. Now, if you look at the graph, you can even see that the lines match up where we had them. So 1 box is where the high line is, the second box is where it crossed over, the third box is where it dipped down.
No, mine is showing like the graph lines.
The X and Y axis. It might be that your axes are turned off. I will have to mess with your calculator a little bit.
What did you put?
You can hit second plus 712 and just reset your calculator. And type it again. Say it again.
What did you put for the X max?
2 pi.
And the X.
X scale, I did pi divided by 4. Okay, let's check. Let's go ahead and do this one. So for this one, if I want to see the whole right side of the screen, then I have to do from 0 to 8 pi. So this is example number 3. So I'd have to do from 0 to 8 pi. Now this time 1 box doesn't equal 1/4. How much does 1 box equal this time?
1/3.
1/2. So 4 boxes was 2 pi, that means 2 boxes is 1 pi. So this time for the X scale, I would do pi divided by 2. And then this time, what do I have for my Y min and my Y max?
4 negative
4 and -4, so -4 to 4. Did it go by 0.5s? What did it go by? 1s. Okay. So I did 0, I did 8 pi. So since I did 8 pi, it's going to show me all of this. And then for X scale, I did pi halves, -4 to 4, and go by 1s. Oh, but I didn't type my new equation. So ignore that. That's wrong. Let me type my new equation. So -2 sine x divided by 2 plus 1. So I know that x divided by 2 must have been what was in parentheses, because that's the only place where not putting the parentheses wouldn't make a difference, because it's already considered a group. Okay. So now if I graph it, matches what I have.
Wait, wow. What?
Wait, true is Sine.
Did you guys type the equation?
So do you always have to change the
You don't have to, but it's harder to compare it if your window doesn't match what you drew, because then your brain has to figure out the difference instead of just typing in the difference and letting it do its thing.
Is there any way to fast track that?
Do it a bunch of times and get used to it. Like, it only takes me 3 seconds to change mine, but I've done it a bunch to check my answers. So once you do more, yeah. Did you do a little negative? Did you do this negative down here? Or it could be, go ahead and, sometimes if your calculator does error after it graphs it, it could be that you're like sometime you didn't have your cover on your phone or on your calculator, and like down here you have like a typo somewhere down here. So it graphs it just fine, and then it gets to the bottom one and it tries to graph something and then it messes up. So what I would do, anytime you have an error, I would just clear the calculator memory and start over. Yeah. Second plus 712. That's what you type. Second plus 712.
It gave me 7.
Second plus.
So second.
Plus.
Plus at the bottom. Add.
Plus.
Okay, I'm doing the up. I pressed the up button.
Yeah, second plus 712. All right. Before you guys put your notes away, go ahead and do the domain and range. I totally forgot. The domain is always negative infinity to infinity. These, they wave to the left, they wave to the right. The range, -4 to 0. So we look at the very lowest it goes, and we look at the very highest it goes. So -4 to 0.
Is that in brackets?
Because you can equal -4, you can equal 0. Yep, and so the range is always in between two numbers because it bounces up and down. It does not go up forever. It does not go down forever. It always does that bounce.